feel very honoured to have been invited to talk as part of this lecture series, and it's a little bit intimidating being given the job of kicking it off, but I hope that I don't put you off the topic for good. So this is a piece of research which is a joint piece of work with David Statham, who is a PhD student at the University of Edinburgh. And the title is "Do Group Minds Exist?" And like a typical philosopher, I'm not going to answer that question to definitively yes or no. Now, the reason why I'm doing that is not to be difficult or evasive, but because it's a very difficult question to answer. So there are a number of good arguments out there in the literature for group minds, and there are a number of very good arguments against group minds. So what I'd like to do in this talk is just to focus in on some of those arguments and evaluate them and see if they're any good or not. So we can at least identify whether we have good reasons, we have some good reasons to believe that group minds exist or that they don't exist. Okay, so here's the plan of the talk. So in the first part, I'm going to introduce the idea of group minds and just sketch some of the arguments that people give for believing in group minds. Then I'm going to focus in on one particular argument that's very influential recently against the existence of group minds, and that's what you could call a simplicity-based argument against group minds. It's the idea that positing group minds is positing more than we need to in the world, that we can get by in our explanations with just commitment to individual minds. So that's a particular argument against group minds that I'm going to focus on. Then I think it's kind of helpful whenever you're looking at these general arguments for and against group minds to have a particular case in mind. So I'm going to look at the case of Microsoft just to have a kind of a group to think about. And then we get to the real meat of the talk. So this is really assessing this particular argument against the existence of group minds, the simplicity argument against the existence of group minds. And I'm going to look at two potential problems with that argument against group minds. One is how you measure simplicity. So we're going to look at a few different ways in which one could measure simplicity and see whether they work against group minds. And the other is a general form of argument which is called the inference to the best explanation argument against group minds. Okay, so more on that shortly. And then I'm just going to make a few remarks by way of conclusion. Okay, so on to the first bit, group minds. So whenever one thinks about commercial companies such as Microsoft or Google or Apple, or public bodies like the Department of Defence or the Health Service, or institutions like University College London or the Royal Institute of Philosophy, these organisations, these groups do things in the world, they act in the world, and they don't act in a kind of a blind manner. They don't just flail around. They act in what appears to be a purposive way. They're sensitive to information coming into the organisation. They process that information in sophisticated ways. They collect it together, and the organisation as a whole reaches a decision about action to take, and the organisation acts in that way. And often it's held to account as a corporate body for its action. So if you look inside these organisations, often they're vast. So as we're going to see in the case of Microsoft, Microsoft has nearly 100,000 employees worldwide. It's an absolutely vast, very, very complex organisation. And whenever you look at the way in which that organisation is structured, one can see that in some ways it's similar to the way in which human individual minds are structured. Okay? So there are bits of that organisation which are devoted to collecting new information in from the world. There are bits which are devoted to processing that information, storing that information, keeping a record of it, and forming plans, collating information, comparing different alternatives, and then acting and dealing with the consequences of those actions. So in many ways, at least in certain contexts, groups like these can be treated as an agent. Okay, so the entire body, the entire group, whether it's Microsoft, Apple, or whatever, can be treated as an agent that's making decisions. And that agent has something like a mind. It has something like belief states, something like desire states. So it has certain things that it holds to be true, that guide its actions. It has some things that it would like to happen, which also feed into its decision-making process. And it has something vaguely approximating mental states. Now, the group mind hypothesis is precisely this. It's the claim that groups have minds over and above those of the individuals involved. So the group mind hypothesis is that these states that the organizations have that guide their action, that feed into their plans and so forth, aren't just like mental states, they genuinely are mental states. And the groups, those mental states that the groups have, exist over and above the mental states of the individual members involved in the groups. So, for example, recently in the Deepwater Horizon case, one of the questions that was raised was BP aware of certain risks involved in the kind of drilling that it was undertaking. Now, the question was the organisation, was the corporate body as a whole aware of those risks, not whether any individual employee was. Okay? So it may well be that no individual employee was aware of the risks, but the corporate body as a whole could have been taken to be aware of those risks. So it's states like that which we have in mind in this debate. So candidate group mental states. So if we take the example of Microsoft, so it may well be that Microsoft believes that it can dominate the smartphone market. So even if all the employees within Microsoft have a pessimistic attitude towards whether it can, dominate the smartphone market, it may well be that the organization as a whole takes it to be the case that it can do this and acts and plans on that basis. It may be that Microsoft wants to increase its share of the smartphone market, so it may well be that the plans that the organization as a whole develops and acts on and engages individual employees into are plans to increase the share of the smartphone market. It may be that Microsoft intends its release of Windows 8 to accomplish this, to accomplish increasing its share of the smartphone market. Okay, so organizations appear to be capable of intentional action. They appear to be able to be capable of acting in ways that fulfill the organization's plans and intentions. And suppose Microsoft releases Windows 8 and there's a disaster, its web page the web page goes down, you go to their web page, it's not there. What do they post up? They say that they regret that the web page is currently unavailable. Okay? Now, that doesn't mean that any individual employee regrets that the web page is unavailable. It seems to be reporting that the organization as a whole is expressing an attitude of regret that the web page is unavailable. Okay? So when you're delayed in your train journey and you get the message from First Capital Connect that, we apologize for the delay in your train service, it may well be that none of the employees in that company have particularly strong feelings about whether you're delayed or not in your journey. But the claim is that the organization as a whole is capable of expressing regret, is capable of apologizing for your delay, for your delay. That's the claim that there are group minds. So the claim is that these groups, these organizations, are capable of having mental states like beliefs, like desires, like intentions. Strictly speaking, attributions of beliefs and desires, intentions, and so forth to organizations like Microsoft is false. It might be a useful way of speaking, but it's strictly speaking false. There are no group mental states. And the argument is very simple, and it's in many ways very appealing. The argument is that group minds violate some simplicity principle, which is some variant of Occam's razor. So Occam's razor says you shouldn't, whenever you're theorizing about the world, multiply the entities beyond necessity. You should only posit the minimum required in order to explain the data that you have available to you. So Isaac Newton puts this very well. He says, admit no more causes of natural things than such as are both true and sufficient to explain their appearances. So you shouldn't posit entities beyond necessity. Now, if you think that's a reasonable principle, and you observe that in many of these cases where we talk about groups having mental states, Microsoft desiring to do something, if you observe that in many of these cases, simpler individual level explanations are available, so it's possible to explain why Microsoft did something without mentioning the organization as a whole having a mental state, then you might think, well, we've got no reason to posit group minds. Positing group minds is something which is metaphysically profligate. It's positing more than we need to posit in order to explain the data because there's a simpler individual level explanation available. So it's a very kind of powerful argument, the thought that, you know, if you can explain everything that's going on in the world without mentioning group minds, then there's no reason to think that group minds exist. And this claim has been endorsed very, very widely by a number of influential people recently. So my claim is that these simplicity arguments against the existence of group minds don't work. So they may seem to be very appealing, but they don't actually work. Okay. Now, before we get to the argument against group minds, it might be helpful to think a little bit about why someone would believe that they exist in the first place. So why do people think that organizations or groups or bodies have mental states? Well, there are three powerful arguments out there which people appeal to. So I'm not going to go into these in detail, but I'm just going to put them out there just so that you get a feeling of the kind of motivations that people have for believing the existence of group minds. The first is the argument from mismatch, the second is the argument from stigmergic patterns, and the third is the argument from functional similarity. So let's just quickly have a look at those. So the argument from mismatch. So this is a very common observation that people make in the literature on group minds, and that is that groups often produce judgments, they produce actions, and those judgments are often not endorsed by any member of the group. Okay? So I mentioned a few possible cases before already that, you know, every employee in Microsoft might be pessimistic about its project, about its prospects, but the organization as a whole might be optimistic. The classic case for this, where groups have produced a judgment which is not endorsed by any member of the group, is the US Supreme Court. So the Supreme Court might produce a verdict which none of the individual members endorse because they have to produce a judgment which is consistent with past precedents. Okay? So the judgment produced by the body is not held by any individual member of the body, any individual member of the group. And the way in which people interpret this data is that they say, well, the best explanation is to say that the Supreme Court judges that X. So they say that the best explanation is to involve positing a group mental state, that in addition to the individual members, there's also an agent, which is the Supreme Court, and it has beliefs, it produces judgments, and those exist over and above the individual judgments of the individual members. So the thought is, to explain this mismatch, we need to posit group mental states. Okay. Now, the rejoinder that's often made to this is that that mismatch between the individual's judgments and the judgment of the body as a whole, you don't need to posit group mental states to explain that mismatch. That mismatch can be explained in terms of the individual mental state. So you can tell a much longer story involving just individual members' mental states about how those members got into discussion, got in disagreeing with each other, had to look at what the past precedents were bound by those past precedents, and had to produce this judgment. So you can tell a story about why a particular judgment was issued without mentioning anything to do with mental states of the entire group. Okay? So that's the argument. That's this kind of standard first objection to the argument from mismatch. The second argument that people tend to draw on to believe in group minds is what's called the argument from stigmergic patterns. So stigmergy is a wonderful word. It was coined in the 1950s to describe what happens when you've got a bunch of supposedly dumb individuals, or individuals which aren't being particularly clever in problem solving, but they're organized, they're orchestrated together in quite a clever way, and they're able to, as a group, to solve tasks which the individual members would be completely unable to do. So it's to describe where you get intelligent behavior from a group of dumb individuals, okay? So it was originally coined in 1956 to describe the behaviour of termites. So that's, in the picture there, you can see two termite nests. So termites build these absolutely wonderful structures which are incredibly complicated. You know, they include air conditioning, they're fantastically detailed and complex. Yet the individual termites are incredibly simple organisms. They have very little cognitive powers, and in addition to that, they're blind. Okay? So if you think, it's like, you know, a group of human beings getting together and building a cathedral. by themselves, being completely unaware, not having any plans, not having any blueprints, and being completely blind. So it's an absolutely incredible feat, but it's done with very, very simple organisms operating together. So this kind of phenomenon of intelligent behaviour of a group arising from quite dumb individuals coordinated in clever ways appears all over the place in nature. So another kind of classic case is trail building by ants. So if ants have the problem of how to construct trails to optimally get to their food sources and back to their nests, and it's actually quite a difficult problem to solve. So if you were, trying to do it in the abstract, it's quite a tricky optimization problem to solve. However, the ants solve it, even though the individual ants aren't, taking an overview of the problem and solving it from the point of view of an outside observer. So just by coordination in terms of the kinds of pheromone trails that they lay, the ants are able to solve this incredibly complex optimization problem in an optimal way. And it's not just organisms like termites and ants, also human beings. So the network colouring problem. So this is the problem where if you're colouring in a map and you want to make sure that no two countries which are beside each other are the same colour, you want to make sure that every adjoining country is a different colour. That's actually quite a tricky problem to solve. But if you take a group of people and you assign each one to a country and you say, well, you just choose a different colour from your neighbour, then the group as a whole will solve the problem very, very easily. Okay? So the thought is that this occurs quite often in human activity, that we solve difficult problems by working together and breaking down the problem in very simple ways. And the thought is that the best explanation of intelligent behaviour in this case requires something like positing group mental states, that the group as a whole is intelligent, is able to solve problems, has beliefs about what the current state of the environment is, and is able to provide optimal solutions to those problems. And the standard rejoinder to this is again a simplicity argument. It's that those stigmergic patterns, those very impressive intelligent patterns, can be explained just as a side effect of individual mental states. So positing group mental states is not strictly speaking required in order to explain this. You can just explain it as a side effect of individuals interacting with each other. The final argument, which is, I think, probably the most powerful argument for group mental states, is the argument from functional similarity. And this is the thought that certain mental states, such as beliefs and desires, have functional natures. What it is to have those mental states is just to be disposed to act and to react in certain ways, and for those states to have certain causal roles in your mental life. So if mental states have functional natures, if what it is to have a given mental state is just to be disposed to be pushed around by information in certain ways, then there's no reason why groups can't instantiate those functional properties as well. So if what it is to have a belief is just for certain information in the environment to cause you to have that state, and for that state to combine with certain desires that you have to cause you to act in certain ways, then there's no reason why groups can't behave like that as well. And that's exactly how the groups which I've describing have been behaving. So Microsoft acquires information about its current state of its environment, stores that information, combines with plans, and produces action. So if that's all there is to having a belief, then there's no reason why groups can't have those beliefs. So again, what people have done is they've appealed to the simplicity argument to try and undercut this. So they've said that even if there's a functional match, so even if the group is behaving as if it had a belief, so it's behaving with the same functional role, that evidence is undercut by the availability of individual level explanation. So the fact that you're able to tell a story just involving individuals about what's going on undercuts any evidence that you get from functional similarity. Okay, so what I want to point out is that in each of these three cases, so in the argument from mismatch, the argument from stigmergic patterns, and the argument from functional similarity, in each case we've got an argument that appeared to show that group minds exist, and in each case that argument appeared to be knocked down by the existence of individual level explanations, so explanations which just don't appeal to the existence of group minds. Okay, so before we go any further, I just want to mention a couple of points to keep in mind. So the first thing is that when we're talking about group minds, the claim is that group minds actually exist now. So it's not regarded as particularly controversial that it's merely possible group minds could exist, or that you could dream up some science fiction scenario in which group minds exist. The claim is that certain organizations right now do have mental states. The other thing to point out is that, well, you might think group minds are kind of implausible, because it's implausible that an organization like Microsoft could have a mental life just like you, or just like a human being. But that isn't the group mind claim. So the group mind claim isn't that organizations have a mental life which is identical to human beings. It's just the claim that they have some probably quite primitive form of mental life. So they have some mental states, such as beliefs and desires and intentions and regrets and so forth, but they might not have the full richness of a human being mental life. And in particular, in the arguments that I'm going to be considering anyway, and most people in the literature would like to exclude conscious aspects of human life from the group minds claim. So the claim isn't that organizations like Microsoft have consciousness. Okay? The claim is that they have other mental states, which play a very important role in your mental life, beliefs, dispositional beliefs and desires and so forth, which drive you to move around. So they have some form of mental life, even if it falls short of exactly the kinds that we humans enjoy. But it's controversial enough to claim that they have any mental states, okay, even if it's not the full complement that we have. Okay, so I think it's helpful to keep in mind before we go any further a particular case, a particular example. So I want to look at the example of Microsoft. So let's consider the question of how does Microsoft develop a new operating system? So last year Microsoft released Windows 8, and one might ask the question, well, how did it develop that operating system? And you might give two different kinds of explanations to that, one of which just involves individuals' mental states, and the other appeals to group mental states. Okay? So let's try and evaluate each of those explanations to see which one is better. So the claim which is made by the critic of group minds is that the group level explanation is not necessary. You can tell a full story just in terms of the individual level explanation. So you're not committed to group minds. So they claim that the availability of an individual level explanation shows that we're not committed to group minds. But let's just try and get each of those explanations in a bit sharper focus. Okay, so first of all, individual level explanation of how Microsoft developed its new operating system. Well, the story that's going to be told is something which is going to involve a lot of different resources. So Microsoft is an absolutely vast organization. So just in the headquarters in Redmond, there's 8 million square feet of office space. It's an absolutely vast place. There are many, many employees. And those employees are not just moving around in a disorganized way. They're grouped into a very complicated structure with moving parts. So they're grouped at the moment into around about 12 large groups or divisions. So divisions such as operating systems engineering, devices and studios engineering and so forth, applications and services engineering. So these are the big divisions within the company in which people exist. And there are subgroups within each of these large groups. So their subgroups have many different products. So, they have Windows, they have Windows Server, Windows Live, they have Microsoft Office. So they have lots of different products within that. So individuals within a particular group will also belong to a given subgroup. And there are also going to be units within each subgroup. So even within just the Windows subgroup, there are going to be smaller units or teams within that group dealing with particular aspects of the development of the operating system, dealing with the file system, with the user interface, with the kernel, with the drivers. And within each unit, so even within the unit which is dealing with the file system, there are going to be individual teams within that unit and different people within those teams dealing with different aspects of the problem. So there'll be people which are devoted to just doing implementation stuff. So there's people who are kind of the low-level coders who are given a task to do, small subtask, and their task is just to implement things. You might get people who are a little bit higher up, or team leaders who are involved in drawing up the architecture for a given for a given area. You've got people involved in the documentation, in the testing, and with communication with other units. So it's a very, very complicated structure where people belong to units at many, many different levels, and those units interact with each other and compete with each other and share information with each other. So it has the organization as a whole has a very, very complicated functional structure. There are a lot of employees, nearly 100,000 employees, and in addition to those employees, there's a lot of stuff which gets moved around and a lot of ways in which information is transferred between individuals and stored. So there's lots of equipment and emails and memos and face-to-face chats and record keeping. Okay, so suppose you give an individual level explanation of how Microsoft produced its operating system. So that explanation, you're only allowed to refer to mental states of individual employees and interactions between those individual employees. What you're going to get is a really dizzyingly long and complicated explanation. Okay? You're going to get something which is fantastically complicated and dealing with many, many people and their interactions, the details of their interactions. So that's fine, but it's worth bearing in mind just how complicated and detailed the individual level explanation is going to be. What about group level explanation? So what happens if you explain and allow for in the existence for group level mental states? Well, group level explanation has exactly the same resources and the same commitments as individual level explanation. So it's committed, just like individual level explanation, to individual mental states and all the equipment and all the resources and so forth. All that's going to feature in the explanation. But it adds an extra resource, which is group level mental states. So it allows for the existence of individual groups within the organization to have mental states in addition to the employees having mental states. Now, your immediate reaction to this would be, well, why on earth would that be useful? Okay? So we already have tons and tons and tons of stuff to feature in the explanation. You're just giving me more stuff to put in the explanation. It's going to get even more complex and difficult to follow. But it turns out that adding group-level mental states is an incredibly powerful device because it allows one to simplify the explanations one gives in very, very powerful ways. And that simplification is possible because the units within Microsoft, the individual groupings of people, those big groups, the subgroups, the teams and the units, they don't act in a random way. They act in a coherent and integrated and in many ways rational way in the sense that they're optimizing whatever their particular plans and their particular beliefs are. So those individual units, they make judgments. So there's a take that a given team has on a particular problem or a particular issue. They form opinions, they explore options. So the team as a whole has particular takes, and those takes are taken up and compared with those of other teams. They form beliefs, they have intentions, they respond to input, and they act on other groups. So the teams as a whole act in agential ways. They act like mini agents. And it's not just their behavior. So it's not just that they behave like mini agents. If you look at their internal structure seems to mirror that of many agents. So their internal structure involves acquiring information and processing that information, storing that information, respecting integrating it with past information, respecting the coherence with past information, and producing various outcomes. So this way of describing what's going on within the organization, where you're not restricted just to referring to individual mental states, but you're allowed to group individuals together as mini agents and describe the interactions between those mini agents, how they're competing with each other or cooperating with each other or reaching consensus with each other, allows us to describe those dizzyingly complex patterns in a very concise way, which also is incredibly useful for prediction. So it's very robust in being able to predict how various groups are going to react under various circumstances, which you're not going to immediately get from the long, complicated story about individuals' particular behaviour, particular reactions. So the group level explanation is powerful. It allows us to simplify the kinds of stories that we tell in a very helpful way. So rather than having this long, unwieldy story, we can tell a much, much more concise story that also has a great deal more predictive power. So we've got two possible explanations of how Microsoft produced its operating system: individual level explanations, where we're just restricted to referring to mental states of individuals, and group level explanations. And it's worth noting that both have their advantages. So the individual level explanation appears to have the advantage that, in a sense, it's committed to less stuff. It's committed to all this stuff in the environment, but it's not committed to group mental states. Okay, so we're going to explore it in a little bit more detail, what it's meant by being committed to less stuff. But in some sense, it appears to be more parsimonious than the group level explanation. The group level explanation has the advantage that it's just less complex and long-winded, so you don't have this dizzyingly complicated web of interactions between 100,000 different people. You can simplify that into interactions between various groups, and that simplification can be incredibly useful because it can yield tremendous predictive power. Okay? So in certain circumstances, of course, you might want to drop down to individual level explanation, but the claim is just, in some circumstances, group level explanation, where you group the individuals together and look at the properties of the groups, is going to pay off. It's going to have advantages. Okay. So let's look again at the simplicity argument against group mind. So the simplicity argument starts with the observation that the individual level explanation, the long, dizzyingly complex explanation of how Microsoft developed an operating system, is just more parsimonious. Okay, so it's not committed to group mental states. So it explains the same thing as the other explanation, but without this extra metaphysical commitment to group mental states. It also relies on the assumption that individual explanation of group behaviour is always available. So I'm not going to challenge this assumption, but people spend quite a bit of time arguing that in any case of group behaviour, so anything that the group does can be explained purely in terms of the actions and mental states of individuals. So if individual level explanation is more parsimonious and it can explain everything that the group behaviour can explain, then why on earth should we appeal to group mental states? So we should just eliminate group mental states from our ontology. So this is an argument which has been made by a number of people recently. So this guy here is Rob Rupert, who's made this argument quite prominently in recent papers. And the idea is that because of the availability of individual level explanations, group level explanations are just OTOs, they're just unneeded. Okay, so what I'd like to do now is just to focus on this claim here. So the claim is that the individual level explanation is more parsimonious. And we've been kind of taking that for granted so far. So we've been kind of taking for granted that the individual level explanation, where you don't mention group mental states, is more parsimonious. It's committed to less stuff in the world. Okay? But what does that actually mean, committed to less stuff? In what sense is it more parsimonious than the group level explanation? So how exactly do we measure the amount of stuff that a given theory is going to be committed to? Okay. So in order for the simplicity argument to work, it's important that there is a valid notion of parsimony, which applies in this case. Okay, so how do we measure parsimony? How do we measure which explanation is more parsimonious than the other? So in what respect is individual level explanation more parsimonious than group level explanation? Now, it's quite tricky to come up with a good measure that gives the right results. And there are two main approaches. One is what I'm going to call qualitative parsimony, and the other I'm going to call quantitative parsimony. Okay, so first of all, qualitative parsimony. So qualitative parsimony concerns the question of how many kinds does a particular theory or a particular explanation posit? How many kinds is a theory committed to? And the idea is that everything else being equal, we should prefer theories which posit less kinds in the world. Okay? So that's what it means to be more parsimonious, is to posit less kinds of stuff in the world. So one example of this, so as we're going to see a bit later on in the talk, all of these examples are actually much more complicated than they first appear. But one sort of simplified example of this is the case of caloric fluid. So that's Antoine Lavoisier, who played a key role in the removal of caloric fluid from scientific theories. And one consideration that was brought to bear, among many others, was that caloric fluid was an extra kind of stuff in the world over and above what was strictly speaking needed to explain the data. So one important piece of data that caloric fluid was appealed to explain was heat flow. So the thought was that whenever one heat flows from one body to another, then that involves the flow of some fluid, caloric fluid. Now, both the advocates of caloric and the people who didn't believe in caloric thought that molecules existed, that there was such a thing as molecular motion, that these bodies were composed of molecules. However, one of the reasons why caloric was abandoned was because it was shown that you could explain the phenomena of heat flow without appealing to the existence of caloric fluid. So caloric fluid was simply not needed. You could explain everything that you needed to explain about heat flow just with molecular motion. So both sides accepted molecular motion. One side also had caloric fluid in its ontology. Caloric fluid wasn't needed to explain the data, so caloric fluid got thrown out. It was just eliminated because it was superfluous. So the idea is that we should minimize the number of kinds of things in the world, and that's kind of a good rational principle, everything else being equal whenever we're building our theories. Does qualitative parsimony count against the existence of group minds? Okay, so are group minds violating qualitative parsimony? So the group mind hypothesis definitely posits additional cognitive properties. So it attributes cognitive properties to groups, organizations, but it doesn't seem to posit additional kinds of cognitive properties. Okay? So it's not positing new types of mental states in the world, new kinds of mental states in the world. It's attributing beliefs and desires and intentions and so forth to organizations like Microsoft and Apple and so forth. So it doesn't seem to involve an increase in the number of kinds of mental state in the world. It's the same kinds of mental state, it's just you're attributing it to other individuals, not just individual people, but also to groups of people. And in a sense, this is why the group minds hypothesis is interesting. It's saying that there's an important similarity in our mental life between us and organizations which comprise of many people. Okay? So if you were to say that an organization had mental states, but those mental states were nothing like any human mental state, it would be unclear why that hypothesis would be interesting at all. So it doesn't seem that the group mind hypothesis violates qualitative parsimony. It's not positing additional mental kinds in the world. It's the same old mental kinds, but just attributing them to other kinds of individuals. A different measure of parsimony is, instead of asking, well, how many kinds of things are in the world, you can ask, well, how many instances of the kinds do you have? And you may think that it's a reasonable principle to say that everything else being equal, you should prefer theories which posit the minimum number of instances of a kind needed to explain the data. So an example of this comes from the original introduction of neutrinos by Wolfgang Pauli. So Daniel Noland has a wonderful discussion of this case. So neutrinos were, one of the reasons for introducing them was to explain a deficit in mass energy in beta decay. So in beta decay, you get certain products out of the beta decay, but the amount of mass energy at the end is less than the amount of mass energy that you start with. So there's a deficit which needs to be explained. So it must have gone somewhere. And the thought is that it goes into, one of the places that it goes to is into a particle, a neutrino. However, if you just take that piece of data as it is, that deficit, that mass energy deficit, could have been explained by any number of new particles. So you could have explained it in terms of adding one neutrino, okay, with the relevant mass energy, or it could have been two new particles with half the mass energy, or three new particles with a third, or 1 million new particles with 1 millionth the mass energy. Okay. Now, of course, there are all kinds of considerations that could be brought to bear to test these other hypotheses, but just set those aside for the minute and think, what is the rational thing to do, just given the data about the mass energy deficit? It seems that the rational thing to do, at least we can argue if you're a fan of quantitative parsimony, is to posit just one particle with a relevant mass energy rather than more. Okay? So everything else being equal, it seems rational to posit the minimum number of instances of a kind needed to explain the data. Okay, so you might think, well, maybe if we take this measure of quantitative parsimony, which seems, at least on the face of it, to play a role in evaluating which explanations are good ones. So does quantitative parsimony count against group minds? So are group minds violating some principle of quantitative parsimony? On the face of it, it seems that they do. So on the face of it, it seems that group level explanations posit extra instances of mental states. So if you believe in group minds, then it turns out there are more beliefs in the world than you thought there are. Okay, so they're the beliefs of all the individuals, plus there's some extra beliefs that groups have. So those are some extra instances of the kind belief. Okay? So in the world there exist all the mental states of individuals plus all the group mental states. So it seems to be violating quantitative parsimony. But things are a little bit more complicated. And the reason why they're complicated is that the relevant mental states that are being attributed to groups are difficult to count. So they're not things like marbles in a box, which you can just count them up. The relevant group mental states are functional dispositional states. So they're states like beliefs and desires and intentions and regrets. Now, if you try and count how many of these states individual people have, so just setting aside groups, so just counting the individual mental states, it turns out that individuals have rather a lot of them. In fact, it seems that they have an unlimited number of these mental states. So if you think about the number of beliefs that you have, so you might have the belief that your house has 6 rooms, but you don't have that belief in isolation. You also believe that you have more than 5 rooms, less than 7 rooms, that you have some rooms, that you have a house. It comes with, so any belief that you have comes with more and more beliefs. So it's difficult to put a limit on the number of beliefs that individuals have. So if you take the case of the CEO of Microsoft, the CEO of Microsoft might intend to develop a new operating system, but that isn't the only belief that he has. He also intends to develop a new operating system that's available to Microsoft's customers. He intends that this operating system will run on existing hardware. He intends that it will enable the use of more than one piece of software, and so on, and so on, and so on. Okay. So beliefs, intentions, desires, and so forth don't seem to be the things that, there are marbles in the head which one can count up. They seem to be the sort of things that are functional dispositions, and individuals have an unlimited number of those functional dispositions. Now, if individuals have an unlimited number of those kinds of mental states, then we've got a problem with measuring quantitative parsimony. So if there are an unlimited number of belief instances in individuals, if you just consider the individuals, then adding extra belief instances via groups doesn't increase the total. Okay? So if you've got an infinite number of individual beliefs, then adding more group beliefs doesn't actually increase the total in any way in which it's in any standard way in which you can measure the cardinality, the size, in any standard way in which you can count it. So eliminating the group beliefs doesn't actually give you a quantitative saving. So it's like you have an infinite set, such as a set of natural numbers, and you eliminate all the even numbers. That doesn't actually give you any quantitative saving because you've still got a set with the same cardinality. So the principle of quantitative parsimony works wonderfully when you've got a finite amount of stuff which you can kind of count up, and you can see whenever you've got an extra thing there, and that's violating quantitative parsimony when you've got an extra thing. But whenever you're dealing with infinite sets, quantitative parsimony seems to be a very, very hard measure to apply. So it's not clear at all that group minds violate quantitative parsimony. So if you accept that individuals have an unlimited number of mental states, which seems quite plausible, then it's not clear that adding extra mental states that groups have is any sort of violation of this measure. So it's not clear that either qualitative or quantitative measures work in the argument against group minds. So that's one thing that nobody's really satisfactorily resolved. Now I want to kind of take a step back from the argument. So that's one problem with the argument, the simplicity argument. So one problem is the simplicity argument is how do you measure how simple the individual level explanation is versus the group level explanation, and it's turns out to be very difficult to measure that all these measures, the quantitative, qualitative measure, don't work. I want to kind of step back and look at a different and more fundamental problem with the simplicity argument against group minds. So let's just assume for the moment that that problem with measuring parsimony is solved. So you might think that, okay, well, these difficulties with measuring whether there are more stuff in the world in the group case versus the individual case, let's just not worry too much about that. It just seems evident that on the group mind hypothesis, you're positing more stuff. So it just seems evident that the individual hypothesis is more parsimonious. So let's assume that that's the case. Let's assume that the individual level case really is more parsimonious. Now, on that assumption that the individual level case is a more parsimonious hypothesis, does that mean that we should eliminate group minds? So does that evidence about the parsimony, so does that assumption about the parsimony mean that we should eliminate the group mind hypothesis? And I'm going to argue that it doesn't. Okay. So if we return to the parsimony principle, that principle was that we should prefer the most parsimonious explanation, all else being equal. So everything being equal, if you've got two explanations of the data, one of which is more parsimonious than the other, forget about how you measure parsimony. Let's assume we've solved that problem, but let's assume that one is more parsimonious than the other. Then you should prefer the most parsimonious one. Okay. The problem is that in the case of group minds, all else is not equal. So whenever you're comparing the individual level explanation and the group level explanation, you're not comparing two cases where one is more parsimonious than the other and everything else between the two explanations is equal. So as we saw in the Microsoft example, individual level explanations, let's just assume for the sake of argument, are going to be more parsimonious. Let's assume that. But group level explanations have their virtues as well. So the group level explanation allows you to tell a much more concise story that's very, very powerful theoretical tool, allows you to make predictions. So it's less complex, long-winded. It allows you to compress very, very complicated patterns involving individuals in a quite concise way that allows you to make all sorts of predictions and tell explanations which appear to yield greater levels of understanding. So the group level explanation appears to have virtues as well. So it's simply invalid to use a parsimony principle like Occam's razor to infer that the individual level explanation is the correct one. Okay? Because all else is not equal. You haven't got two explanations which are exactly the same except that one is more parsimonious than the other. You've got two explanations, both of which have different virtues. One is more parsimonious, but the other one, despite being less parsimonious, has other virtues. So it's not a case where everything else is equal. Now, you might think, well, Occam's razor, well, it's perhaps a very difficult principle to apply because you're rarely going to encounter the case where you've got two explanations where everything is equal between them except one is more parsimonious than the other. But what one could do is one can move to a more general principle, of which Occam's razor is one instance, called inference to the best explanation. So what we've been doing so far is we've been moving from explanatory properties, properties of the explanations that people have been offering, to ontology, to what exists in the world. So we've been going from saying, well, this explanation is more parsimonious than this one, to saying, well, the stuff that this explanation refers to exists, and the stuff that this other explanation refers to doesn't exist. But there's a more general method of going from explanatory properties to ontology, and this is inference to the best explanation. So inference to the best explanation is a method for selecting between rival explanations, rival hypotheses. And inference to the best explanation, what it says is that you should infer the hypothesis that best explains the data in hand. Okay? So it's a crucial method for justifying hypotheses in science, and as we're going to see, it's a more general method of inference under which the parsimony principles we've been discussing fall. So here's an example of its use. It's a very famous passage by Darwin arguing for evolution by natural selection. It can hardly be supposed that a false theory would explain in so satisfactory a manner as does the theory of natural selection the several large classes of facts above specified. It's recently been objected that this is an unsafe method of arguing, but this method used in the judging of common events of life and has been used by the greatest natural philosophers. Okay? So the idea is that you justify the hypothesis in terms of its explanatory value, in terms of its explanatory properties. Here's Lavoisier arguing, in this case, for the existence of oxygen. I've deduced all the explanations from a simple principle, the oxygen principle. Once this principle was admitted, the main difficulties of chemistry appeared to dissipate and vanish, and all the phenomena were explained with an astonishing simplicity. Okay, so again, you're justifying your ontology, you're justifying the entities that you posit in the world, whether you posit oxygen, in terms of their explanatory benefits, in terms of the kinds of properties that explanations that refer to oxygen have. So an important feature of inference to the best explanation is that it uses explanatory properties as a symptom of truth, as a symptom of what actually is true in the world. So what are the relevant explanatory properties? Well, there are a bunch of them that inference to the best explanation considers as a kind of a bundle. One of them is parsimony. Okay? So the kind of principle that we've been looking at so far, which says, well, the most parsimonious explanation is the one that you should prefer, that falls under the heading of inference to the best explanation. So this is a more general method that encompasses the reasoning using parsimony. But that's not the only explanatory virtue. There are other explanatory virtues, so you might, one explanation may be more elegant than another. One explanation might yield more understanding. It might be able to be more predictive. It might have a broader scope, so it might cover more cases. It might unify phenomena that another explanation doesn't unify, and it might be more fruitful for future inquiry. So these are all properties of the explanations that we can offer, and the thought is that some combination of these, if your explanatory properties are good, so it assumes that if explanatory properties, they don't just give you a nice explanation, which is something which is good to have in itself, but something which is a good explanation is also likely to be true. Okay. So inference to the best explanation assumes that explanatory properties are a guide to the truth. Now, there are a couple of conditions in order for inference to the best explanation to work. So you might think that, well, inference to the best explanation is going to help us solve our problem. So our problem was that the standard parsimony principle wasn't working because the two explanations, the group level and the individual explanation, weren't equivalent. So it wasn't the case that all else was equal between the two of them, except one was less parsimonious than the other. Inference to the best explanation allows us to put those two explanations into competition because it allows us to weigh the different explanatory virtues. So it allows us to say, even though the one might be more parsimonious than the other, one might have greater benefits in terms of elegance or simplicity or unification. Okay, so this is potentially a framework which allows us to get around the problem that affected just the application of the parsimony principle. So in order for inference to the best explanation to work, there has to be a clear winning explanation. So inference to the best explanation says that you should infer the explanation which has the best explanatory properties. Okay? So it has to be the best, score best on all of these measures or some combination of these measures. There's no algorithm for determining this, but the thought is that there are certain clear cases where something does well on some combination of these and something else does very, very poorly on some combination of these. Then we can say that inference to the best explanation justifies you in inferring that the one which does well is more likely to be true than the one which does poorly. But in order for it to work, there has to be a clear winner, and we have to be capable of detecting which is the best explanation. So it's no good if one explanation is better than the other, but we're not able to judge which one is the best. So if that's not the case, so if there's not a clear winner, such as this kind of case here. If you imagine that these ladies all cross the line simultaneously, so you have explanations which are their net explanatory value. It's difficult to tell which is better than the other. Okay, so they both offer, they both have their virtues, but it's difficult to tell which is the better explanation than the other. Then inference the best explanation is just no help in deciding which of those hypotheses is correct. Okay, so it's a method of inference. It's a powerful method of inference in science, but it's a method with its limits because it's only going to help you to discriminate between rivals which do clearly vary in their explanatory value. Okay, so can we use inference to the best explanation to argue against the existence of group minds? So we can try and construct a revised argument. So instead of arguing that individual level explanation is more parsimonious, we can instead argue that individual level explanation is simply better, all things considered. Okay? So it's better on some combination of all of those metrics. Then we can add the assumption that individual level explanation of group behaviour is always available. So that is something which I hadn't been questioning so far, that whenever you give an explanation of group behaviour, you can always tell a story which just involves individuals. Well, if that's the case, then we can just apply inference to the best explanation and say that we should eliminate group level mental states from our ontology. So we should assume that the individual level explanation is true and the group level explanation, because of its inferior explanatory value, is false. Now, unlike the previous argument, this has the advantage of being a valid argument. So it's a valid application of inference to best explanation if you accept that as a method of inference. But the difficulty is, well, why should one accept the first premise? So why should one accept that all things considered, individual level explanation is better? Okay. So as we saw, individual level explanation, we're going to assume for the sake of argument is more parsimonious. It posits less stuff in the world. But we saw that group level explanation has virtues that the individual level explanation doesn't have. So it has virtues in allowing you to compress very, very complicated patterns down and be able to describe them in a very concise way and to be able to generate quite robust predictions about them. So group level explanation has its virtues. Which one is the better explanation? So if these are our two candidate hypotheses and we have to judge which one's the better explanation, and we infer the better explanation is true, which one is the better explanation? I think that we're kidding ourselves if we think that there's a clear winner between these two. Okay? So I think that the best thing to say is that in this case we're unable to detect a clear winner. So there's a trade-off whenever you give an explanation between parsimony and elegance. So there's a trade-off between the amount of stuff that the explanation posits and the complexity, or the how complex or long-winded the explanation is going to be. And it's quite difficult to decide what is the correct point to adopt on that in that trade-off. So there's no algorithm which is going to help you do that. There are going to be certain clear cases, but this doesn't seem to be one of them. So in this case, we seem unable to detect a clear winner between the two hypotheses. Both of them are options which one could rationally endorse depending on one's interest. So depending on whether one was interested in explaining certain things, the individual level explanation may appeal. Depending if one was interested in other things, group level explanation may function as the better explanation. So it's not clear that one of them is unequivocally the better explanation. Okay, so the worry is that even if one switches from a simple parsimony argument to an inference to the best explanation argument, as an argument against group minds, it fails. Okay, so the worry is that there's no clear reason for thinking that explanations which posit group minds are explanatorily inferior to explanations which just involve individual mental states. Okay. So to criticise group minds, this isn't to say that the group mind hypothesis is vindicated. It's just to say that to criticise group minds, you've got to move to different grounds. You can't just appeal to their lack of parsimony. The group mind hypothesis has explanatory virtues which may well counterbalance their lack of parsimony. We can actually conclude something which is stronger. So not only does the inference to the best explanation against group minds fail, the problem that we faced was that the group level and the individual level explanations were explanatory ties in the sense that we weren't able to detect which one is overall, all things considered, the better explanation. What this means is that not only does the inference to the best explanation against group minds fail, any inference to the best explanation for group minds also fails. Okay? So if you can't detect which one of these is better, then you can't appeal again to explanatory properties to say that one should accept the group minds hypothesis. So what this does is that it undercuts two of the main arguments for group minds. So the three arguments that I mentioned was the argument from mismatch, the argument from stigmergic patterns, and the argument from functional similarity. So the argument from mismatch and the argument from stigmergic patterns were both inferences to the best explanation. So in the case of the argument for mismatch, the claim was that the best explanation of the mismatch involved the positing of a group mental state. And we've seen that that's exactly the kind of thing which the individual level explanation is going to contest. If you can't run, if it's not clear which is the best explanation, so if there's no clear winner in terms of explanatory value in the round, then this argument, which relies on the assumption that the best explanation involving group mental states isn't going to work either as an argument for group minds. Similarly, the argument from stigmergic patterns. So it required the claim that the best explanation of intelligent behaviour of the group required positing group mental states. But we've seen that explanatory value isn't any guide to truth in this case either, because there's an equivalent hypothesis, the individual level hypothesis. So we can't infer that the best explanation of intelligent behaviour is going to require positing group mental states. So those two arguments for the existence of group minds don't work either. Okay, so just to conclude, I've focused on parsimony arguments against group minds, and I've really tried to focus on two problems. So one problem is that it's unclear how to measure parsimony in these cases. So although one has an intuitive sense that the group minds hypothesis is less parsimonious than the individual minds hypothesis, it actually turns out to be quite difficult to justify why one is more parsimonious than the other. The other problem is that even if the individual level hypothesis is more parsimonious, that doesn't imply that it's the best explanation of the data, because the group mind hypothesis has important explanatory virtues as well. So we can't simply infer that just because it's a more parsimonious thing, we should believe it. And we've seen that this is a problem with arguments both for and against group minds. The important thing to note from this is that the third argument that I mentioned, the functionalist argument, has been left completely untouched. So the important thing is that this in a way will help to clear what are the grounds in which one can argue for and against group minds. A lot of the debate recently has focused on explanatory value. If explanatory value won't work, then one needs to move to other grounds to argue for and against group minds. I think that the functionalist argument is the most promising one. And I'll finish there. Thank you very much.